All right, you guys, so we are in the second lesson of Unit 4, sine and cosine of complementary angles. First thing you need to remember is what complementary means. Complementary means you have angles that have a sum of 90 degrees. All right, so we're on slide number 6. I'm going to open up my GeoGebra and see what I'm looking at. Okay, well, got a right triangle, and I knew that was going to come because trig is really all about right triangles. Oh, did it open it up twice? Yeah, it did. Okay, let me close one. All right. C, the measure angle A and then measure angle A and B and find their sum. How are the angles related? All right, so let's find angle A and angle B. So come up to your angle icon, select angle. So remember, to find angle A, you got to do in a clockwise motion. So click on C, A, B, and we got 22.62. To find B in a clockwise motion, you got to click on A, B, C. So move this so you guys can see. I got 22.62 and 67.38. So angle A, 22.62. And angle B, 67.38. And it says to find the sum. Sum means to add. Now I'll tell you right now, it's going to be 90. These two add up to be 90. And the reason why is because there's a rule that says 3 angles of a triangle add up to be 180 degrees. We're going to learn that in Unit 2. Well, if this one's 90, then the sum of these two have to be 90, because 90 plus 90 is 180. For you non-believers, we're going to get a calculator and prove it. So I'm going to add them together, and it's 90. 90 plus 90 is 180. So how are the triangles related? What do you mean, how the angles related? They're related because no matter what kind of a right triangle you have, the other two acute angles will always add up to be 90 degrees. All right, so I'm going to submit. All right, so 90 degrees, there you go. They add up to be complementary. Question number 2. Measure the lengths of the sides of A, B, C in GeoGebra and compute the sine and cosine of angle A and angle B. Verify your calculations by using the sine and cosine of angle A and angle B using a calculator. All right, so let's see what AB is. AB is 13. BC is 5. AC is 12. All right, so we need to find the sine of angle A. Well, the sine of angle A, here's angle A, is your opposite over your hypotenuse. Remember, Oscar had. Oscar had. So it's going to be 5 over 13. Now, ACT is going to want that as a fraction, so I'm going to keep it as a fraction. 5 over 13. All right, cosine of angle A. All right, so here's angle A. Cosine is your A heap. A is adjacent, heap is the hypotenuse. So adjacent to angle A is 12, hypotenuse is 13, so we're going to have 12 over 13. Now that does not simplify, so I'm going to keep it 12 over 13, like the ACT does. Now if you do it on the calculator, you're going to end up with a decimal. 5 divided by 13 is approximately 0. Was it 38? Okay. And then cosine 12 divided by 13 It's approximately 0.92. All right, so now we're going to do angle B. All right, so angle B is right here. Sine is your opposite over your hypotenuse. So the opposite to B is the 12. The hypotenuse is always the slanted 13, so we're going to do 12 over 13. In my equation editor, I'm going to do 12 over 13. ACT is going to keep it as a decimal. All right, and then we need to do cosine of B. All right, so here's angle B. Cosine is adjacent, which is the 5. Adjacent means next to, over the hypotenuse. So maybe 5 over 13, and again, that does not simplify. So we're going to keep it 5 over 13. All right, so we already know the decimal equivalents. 5 over 13 was 0.38. 12 over 13 was 0.92, so we're going to have 0.92 first and 0.38 second. So they switch on us because our fractions switched. And that will happen every single time. Sine of A and cosine of A will switch with sine of B and cosine of B every time. All right, so we're going to submit. All right, there we go. Beautiful. All right, question number 3, everybody. Check the show sine and cosine of angle A and show sine and cosine of angle B boxes. All right. There you go. I'm going to move that so I can see it. Move that back down. Okay, well, they got the same thing we got. There you go. 0.38, 0.38, and they switch on us 0.92, 0.92. All right. Move point B to various locations so that angle A is approximately 15, and then 30, 45, then 60, then 75. All right, so in each case, record angle A and angle B, record the sine and cosine of angle B, and what's the relationship do you observe? Okay, so I need to change this so angle A is reading 15. All right, so I'm going to have to come up here and move. I'm looking for this to be 15, or as close to 15 as I can get. Oh, there's 15.03. I will take it. Okay, so what have I got to get first? Angle B's measure. So angle B is, if this is 15, this is approximately 75 degrees. So I'm going to put 75. All right, so I need sine of A, which is 0.26. Cosine of A, 0.97. Sine of B over here, 0.97. And remember, I told you they switched, so it's going to be 0.26. All right, now I'm going to change angle A until it's 30 degrees, or as close to 30 as I can get. Oh, yeah, 30.04. I'll take that's pretty darn close. So I got, for first I got to find angle B, which is roughly 60 degrees. Because 30 plus 60 is 90. All right, sine of A is 0.5. Cosine of A is 0.87. And remember, they're going to switch on, so now it's 0.87. And this one's going to be 0.5. All right, we'll change it to 45. Okay, there it is. We'll go that. That's pretty close. 45.08. And angle B is 45. Because 45 plus 45 is 90. All right, 0.71, 0.71. They're all 0.71. All right, change it till it's 60. All right. Oh, 60.03. Pretty close. That means this one's going to be 30 because 60 and 30 make 90. I got 0.87, 0.5. And remember they switch. So it's going to be 0.5, 0.87. All right, last one, 75 degrees. I don't know that I can get it that tall. Now I can't see angle A. Come over. Okay, there we go. Oh, shoot, I had 0.75. There we go, 75.08. I'll take it. All right, that means angle B is 15 degrees because 75 plus 15 is 90. All right, sine of A is 0.97 and cosine of A is 0.26. 0.97, 0.26. And remember, they switch on us. So 0.26, 0.97. All right, so let's see. What did I have to answer here? What's the relationship do you observe between the sine and cosine of A and the sine and cosine of B? They switch on us. So let's see. What can I say? I can just say they switch. They switch being equal on us. I'm sure there's a better way to put that. Ah, okay, I see how they want it written. So sine of A and equals cosine of B, and cosine of A equals sine of B. So that's how they switch. All right, so look at triangle ABC and the definition of sine of A and cosine of B in terms of side lengths. Based on the definition of sine and cosine, explain what you observed in the previous parts of the activity. Use the equation to support your explanation. Okay, so basically they're asking this right here. So it's going to be sine of A equals cosine of B because they switch on us. And then cosine of A will equal sine of B because they switch on us. Okay, here we go. Yeah, sine of A, cosine of B, cosine of A, sine of B. All right, awesome. All right, question number 5. What general conclusion can you draw about the sines and cosines of complementary angles? State your conclusion in words and in the form of equations. Okay, so complementary. I think they're asking for the formula here is what they're asking for. Okay, so here's the formula. So sine of A equals cosine of 90 minus A. And the next one is cosine A equals sine of 90 minus A. Get my fingers to work here. Pretty sure they want those formulas. Is that what they're asking for? Yeah, it is. Okay, good. They're asking for the formulas. Sweet. All right, so the reason why it's 90 minus A, because remember these two angles add up to be 90 degrees. That's what complementary means. All right, there's my self-evaluation. All right, so the takeaway from this is really this right here. Sine of A and cosine of B are the same. Cosine of A and sine of B are the same. I've seen this on of your standardized test before, and you know, this is a really good thing to have for ACT because you know they're going to be the same. All right, well, this is 6 out of 11, so that might be the only one we're going to find on this sine and cosine of complementary angles. So there we go.